Back with you and with this esteemed panel here to talk about one of the more important issues that we have facing us as a society, as a community of researchers and technologists, how we do the innovation at the very edges that we want to do while also benefiting society. So I'm just excited to get us started here. And I'm going to pose to each of the panelists a unique kind of initial question to answer individually, and then they're going to introduce themselves in the course of answering their questions. And we're just going to dive right in. So I'm going to get started with Professor Janet Abate. Thank you for being here. So Janet, to you, how can looking at computing technology as part of a larger social technical system help us to avoid unintended negative consequences?
Thank you for that question, Dr. Nelson. I am a professor in the Department of Science, Technology, and Society at Virginia Tech, here at our Northern Virginia campus. So thinking about technology systemically, I'll give you a few examples. One is we need to think of the user as an active part of the system. So rather than assuming that the tech designer has all the answers, can we build systems that are open-ended, that allow the user to adapt them and add on to them to fulfill their own needs and desires? And here I think the history of the internet is actually a precedent. And of course, Knighterd was instrumental in the further development of the internet. So the internet was designed so that people could add on applications and interfaces at the local endpoints, and people could innovate in this decentralized way. This is how we got the World Wide Web, for example. That was a user add-on that wasn't planned by the centralized, by the people building the system. So this has been incredibly powerful and successful. And yet today we see systems being more centralized, and the user has less agency in being able to modify a system to be the way they want it. So thinking ahead to the next generation of technology, can we make systems that are, again, more decentralized, more open-ended, so that users can also be innovators? We also need to think of the social environment as part of the system. And I think we've heard a lot about this today already. Part of the social environment, to be realistic, is that there is also inequality and discrimination. And so some of the harms that we see from AI and from social media, things like sexism, racial bias, religious discrimination, these harms were entirely predictable to the people in these groups who experience them every day. They were not surprised to see tech being misused this way. And yet, these groups are often not at the table when technology is being designed, when there might be a chance to design in protections. So we need people who are literate and knowledgeable about the social environment to be there at the design table. But there's also positive aspects. There are strengths in the social environment that we could leverage. Tawana Dillahunt at the University of Michigan talks about strength-based approaches to tech design, where you can look at a community and see, even if it's a low-resource community, it has strengths. People have resilience. People have community bonds. And you can build technologies that leverage those strengths so that you don't just see the weaknesses, you see the strengths. So we need to see the social environment both as something to protect people from and something that we can elevate. And of course, there's the natural environment is also part of the system. And we need to think about the entire technology life cycle, from raw materials to disposal, because that's all part of the system. And the Earth is a finite resource. So can we build technologies? Can we think about researching and designing technologies that make less use of rare earth metals, which are often environmentally destructive to extract? Can we make technologies that are more durable and recyclable so that we can reduce e-waste, electronic waste that's often toxic? Can we make technologies that are more modular so you don't need to discard a perfectly good phone just to upgrade one component? Can we make blockchain to be less energy intensive and have less of a carbon footprint? So these are all parts of the natural environment, that are not only part of the system, but they're part of the public interest, and we need to include them. And I'll stop there for now. I'm sure I can say more about this.
Well, it's great. Thank you for getting us started. I mean, I so appreciated your response. And of course, I was sort of seeing, as you were describing, the user, the social, and the earth, right, these kind of concentric circles as a way of thinking about the socio-technical system. I think it's a really helpful model. All right, so I'm going to turn now to Ramaya Krishnan, Dean Krishnan. Over to you. How do we, or what do we need to do to realize the value from deploying technology in support of societally relevant and consequential decision-making tasks?
Thank you, Dr. Nelson. I'm going to build on what my colleague just talked about. I think the systems framing is particularly appropriate in my view. So in particular, if you think about, let me use a couple of examples to illustrate perhaps a different lens on what that systems framing actually offers. If you think about the deployment of cognitive tutors, which is a kind of AI, along with human teachers in the classroom to help kids achieve in a verifiable manner competencies that would allow them to do better at math or do better at reading, and help each kid at every decile of the ability distribution. That's a very concrete context, a socio-technical context in education. And if we as computer scientists went in to offer such a solution without a partner who knew that context well, as in people who knew education well or social science well. So I think it's really essential for us to think about responsible uses of computing stem from a partnership between computer scientists and colleagues in sister disciplines that know the context, that know the environment well, so that through the work together, something really amazing happens. So that's a very concrete example. Another view of system, which is perhaps more technical, has to do with, if you think about, and in this I'll use an AI kind of context, where you go from thinking about a problem, scoping it, identifying what the data are that are required to solve the problem, understanding how it should be acquired, thinking through ways in which it could be representative in an inclusive fashion of what it is and who the different stakeholders are of the problem. Going on to actually designing or using a model and estimating the model, which is the next step in this pipeline. Designing an intervention of which the technology piece may be a piece, but not the entire piece of the intervention. And then one evaluates the intervention to determine what the impacts are of the intervention. Are they disparate? Is the treatment disparate? The disparate treatment, disparate impact point of view. So if you think of that pipeline of going from problem and data to AI and model to designing the intervention to evaluating the outcome, oftentimes there's a very siloed view of each of these steps. Another systems point of view in how one generates value from responsibly using computing and technology in these societal kinds of contexts would be to take a holistic view of this pipeline and think about how these different pieces interact. So let me pause there. 2 points. First one is that problem solving in these contexts will require genuine partnerships, not for the sake of partnering, but a genuine partnership. And second, understanding the pipeline that we are using and thinking of it holistically. So two uses of the word system. In the first case, I was thinking about this in the context of a socio-technical system, building on what my colleague was saying. And the second is more about thinking even the technological pipeline as a system and thinking about how one needs to think about it holistically in addressing the needs of the problem. So,
thank you so much for that. So we've gotten started with models, with theories indeed, and with systems. And I think what's been encouraging about this conversation already and our conversation over the course of today is a growing level, I think, of understanding urgency and sophistication and technological communities about the need to have these sort of bigger perspectives. That leaves us with the question of how. Who are the people we are looking for to be these bridge builders who are working in these pipelines and these systems? So to you, Dr. Estrin, how might we integrate societal and public interest perspectives into graduate education for the next generation of researchers and practitioners who really need to be the leaders as we move to have this kind of human-centered technology?
So I'll do my very brief bio, and this is just such a nostalgic sort of event for, I think many of us. So I am a professor of computer science and associate dean for impact at Cornell Tech. Sunu is a postdoc at our institution. Just a reference to the previous panelist. And we're in New York City on Roosevelt Island. So why this is so nostalgic is certainly as a student and a faculty member, I was witness and beneficiary to what DARPA and NSF did in investing in these technologies, and then what Knighterd more broadly did with the other agencies, and just like floated so many boats higher. And I was a part of the internet community, and even before the web, when the internet was called the internet. And that architecture that really allowed for that decentralized, iterative set of advances from lower level speed of links being able to go forward, and this multiplicity of applications up above in fully decentralized way was not magical. It was just really excellent engineering design by the folks who started it in those early days. And it was it came to fruition because there was so much investment and use. It was Knighterd and that D of actual development and actual deployment in support of the sciences and research and the research community. Okay, so that was my nostalgia. As an ISAP member in the later 90s, I was thinking about what to do next, right? We've done things in the context of internet, multicast routing, and things like that. And I did a study in what we came to call sensor networks, and even sort of IoT, if you will, and moved from that on into to proposing and winning, that was miraculous, an NSF Science and Technology Center on embedded network sensing. And before that, and before journeying into sensor networks and what we did at SENS, I was a networking person, and applications were like, you didn't do applications. We sort of accepted some token application papers into our conferences, but if you were a real protocol designer, you didn't do applications. And as I moved into these areas, I realized just how powerful it was to engage with applications and real users and the real systems in which this stuff was getting used as an incredibly rewarding motivator for doing the work and driving us in new directions. And so at SENS, and I will get to this public interest in one second, at SENS, we engaged with ecologists and marine biologists and seismologists and eventually people in the health domain to drive what we were developing in terms of developing systems of distributed sensing. And we found that by not only doing tech for its own sake and sort of being adamant about we're not doing tech for its own sake, we're doing tech to serve and to be inspired by and to advance these disciplines, it drew in a greater diversity of students. And in that context and in that time, in particular, more gender diversity and a lot more female students. So when I first heard of public interest tech, particularly this is a movement that the Ford Foundation, New America Foundation have been investing in for several years, and I heard about it from one of our board members. And when I thought about how to bring that to this graduate campus that I'm part of building and creating, I thought about that same question. How can I bring to our technical students, our master's students and our PhD students, the opportunity to build tech in service of public interest and public sector needs, very briefly, just to mention. So we've had Studio as part of our master's program. All the students work together on what started at the beginning to be like startup projects, because the only cool thing to do was to do a startup. And then we grew doing entrepreneurship for bigger companies. And now, based on this public interest tech initiative, we have a public interest tech studio where students pursue either social ventures or even commercial ventures, but designed more around a model of a public benefit corporation with more integrated notions of the communities that they're serving. And we have a PhD Impact Fellowship. So as we know, most of our PhD students, they stay back in the lab some of their summers, and they often go out to Microsoft, Google, Amazon, Apple to do summer internships. So we've introduced an alternative to that. Not instead of, but just take one of those summers if you're interested. And we arrange for externships for those students to go and spend their summer working with public interest and public sector organizations. We didn't say we're going to use this money to go pay a PhD student who has a great idea for how they're going to change the world. No. We said, PhD student, go learn how really serious people have been working in communities and public agencies for many years to try to help those communities. And go work with them and bring them some added capacity, because you're paid by us and you're an internship and you go and work there. So this is these experiences, as with SENS, these experiences of really curating public interest and public sector opportunities for these graduate students to experience as they go through their education, is how we're pursuing it.
Thank you for that, Dr. Ishchan. I hope we will come back to some of what you've raised as well. So, Dr. Isbell, we've had so far some interesting discussion about computing technology as part of social technical systems. But we would be remiss if we didn't sort of switch that vector a little bit and talk a bit about how you see this playing out in everyday system development and machine learning and AI systems, and in what ways we need to adapt the ways that we educate students in the practice of developing these systems.
Well, thanks for that. So I'm Charles Isbell. I'm the Dean of the College of Computing, Executive Director for Constellation Center for Equity Computing, and a professional panel participant. I think that's my second one today. I think this question around the way we train people, the way we teach them how to build these systems, is a fundamental one that leads us to understanding why we've ended up where we are today. So pretend I've already said everything that I said in the earlier panel. I want to highlight one thing in particular, which is, and I've got to say this just right because the words have to end up in the right order. It's not just that we are not trained to care. We are trained to not care, right? So particularly, we focus these problems on, well, the data comes from somewhere. I want to fix the algorithm to build something, and then it'll get deployed. And I only have to worry about this. Or I'm building this system to be an efficient distributor of data across some network through multicast, buzzword, but I don't worry particularly about how it's going to be used. And that problem, which is something that you shared, Krishna, is that it's got to be thought of holistically. You have to think about the entire system or it's a failure. So I think an example of this, if I can use one for a moment, is around ethics. So there's a lot of discussion in machine learning and AI that we need to bring in ethics and discussions of bias. The problem is the way that we build our curricula, the way that we educate people, is that we treat it as something that gets stapled on at the end. And that is guaranteed failure. So for those of you who don't care about this, I'll pick something that you probably do care about: security, privacy, cybersecurity. Everyone who does that for a living knows that if you don't build that in to the system from the beginning and you staple it on the end, it's a failure. The system is poorly designed, you're not going to get security, and it's bad for all. The same is true for thinking about the larger socio-technical system. So I'll just pick on Georgia Tech for a second. So for at least since the end of last century, we have had a required ethics course for computer science. In fact, all of our undergraduate computing degrees. However, although it was a required class for everyone, in fact, it was the first class I taught in 2003 as a young assistant professor, with absolutely no training, by the way. There was a book. I shadowed someone who taught the section 2 hours before I did, and then, I taught it 2 hours later. I was an expert. I'd seen the class. I don't even think I read the book. Anyway, the point is that it was a required class, but it was a prerequisite for nothing. So what happened in practice is that people took it their very last semester. They were deep into senioritis. They didn't care, and clearly we didn't care. because it wasn't integrated in the way that we did education and the way that we built systems. So a couple of years ago, last year officially, we've changed that so that not only is ethics, professionalism, there's lots of different words for it, is a required class, it's now a prerequisite for our junior design, which has two things. One, you cannot do the rest of the computer science you think you're doing until you've understood this, which is important and a strong signal. But also, it means that when you do junior design, which is a year-long multi-semester course on designing and implementing systems in group settings for customers, it's now integrated into the requirements because we know that you've done this already. And so it's already, just in a short time, changed the way that we teach the students, changed the way that we share with them what's important about building systems, that you must think about these things before you go out and you build a system. And this really matters a lot. And for me, it all boils down to something relatively simple. And you've heard versions of this both earlier today and in the comments of my panelists here, my colleagues here. This is a software engineering problem. We have avoided treating so much of the systems that we build as software engineering problems, part of a larger system with design and bringing in all the people who have to be brought in. We've avoided it because it's easier, because we don't care. I'm not sure. But we can no longer do that. And whatever it is we do in the details and changing the way that we educate at whatever level, we must stop avoiding that and making a fundamental thing. So the very first for loop you ever write, you are thinking about these issues.
Thank you so much for that. So I wanted to sort of put you all in conversation and kind of talk across what you raised, because you're talking at somewhat different scales, Janet and Krishnan at the level of systems, and then Deborah and Charles really at the level of what we do on the ground and spaces of pedagogy and training. And so I wanted to ask you to sort of talk across, I think, your visions for what we might do in the future. And I think if we want to think in part about this panel as like launching Knighterd in its next 30 years, it might be one of, into its fourth decade. I would add to that, so as part of this, what should government or Knighterd be doing to help build these socio-technical systems, to build these pipelines, to train students differently? What is the role of, I think, government and the interagency and the coordination piece here in particular, and driving towards the sort of vision and theories that you guys are laying out here? Janet, you want to start?
Sure. So yeah, if I were king of Knighterd, or queen of Knighterd.
Tammy has that job, but when it opens up, we'll let you know.
I think I would try to think about computing and technology in a more interdisciplinary way, so that we include people with different kinds of expertise in a deep way. People who know law, people who know sociology, people who are from and understand different groups in society than we necessarily have. So just thinking about computer science in this much more interdisciplinary way, so that it doesn't get tacked on at the end. And then there's a whole other issue about, which I'm not sure Knighterd can really address, but about the culture of computing and making it more welcoming to people who care about these things. Because, as I think people have mentioned, the sort of signals that we give and the incentives that we have don't reward people who care about equity and justice and privacy and all of the things we've heard about today. And can we change the ecosystem? Is there some leadership role that Knighterd can play to do that? And I'll leave that as an open question.
Thank you for that. Krishnan?
Yeah, I realized I forgot to introduce myself in all my excitement to talk about socio-technical systems. So I am the dean of a college that actually sits at the nexus of technology and social science. So I lead the Heinz College, which is both the information school and the policy school at Carnegie Mellon. And I also lead the Responsible AI initiative at CMU as part of a center called the Block Center for Technology and Society that I direct. I want to use two examples building off of things that folks on the panel have said. I think one has to do with just by way of education, be it at the undergraduate level or we have a joint PhD in machine learning and public policy, and then a new undergraduate program on decision analytics and systems. And this goes to the question of teaching either ethics or how do you build equity and efficiency, and taking all of these things holistically in terms of designing these systems. I think importantly, if you think of many organizations, they all have their top 10 ethical principles. But converting principles into practice, into actual tools, I think if you think about what Knighterd, this whole program could actually help drive, is that translation of policies to practice via tools that actually then could be used for the purposes of understanding if there is bias in the data, if there's ensuring that there are ways in which one could get more representation and representativeness in the data, being able to link in a holistic fashion, as I was pointing out, between data and models and outcomes. Those kinds of things really bring to bear both the contributions of ethicists and more broadly multidisciplinary points of view about equity, efficiency, and ethics, but in ways that then are translatable into actual deployments, actually deployed systems. And if you now are able to combine research, development, and deployment, we call it RD&D, instead of just R&D, it's RD and D, then you have the capacity to build proof points with partners in the community, with partnerships with organizations in the community that not only drive the state of research forward, but then give us really great experiential learning opportunities for students to learn, be they undergraduates, versus just taking an ethics course. They've actually had an opportunity to take that ethics course and learn how that then gets translated into, since we're talking about responsible computing here, about how computing can actually realize those values into systems that actually get deployed. So that's what we're on that journey, and we'd very much like to see that, greater support for this, and I think that's something that would be awesome to have.
Wonderful, thank you. Dean Estrin.
So I'm only an associate. So I think clearly there's so much that this community does to incentivize and shape what the rest of us do, right? As faculty writing proposals, as graduate students choosing faculty with whom they're going to work, their postdocs, determining where where you can have groups that are large, and if groups are larger, you have a room for more diversity and interdisciplinary and collaboration. And back when, even before the expeditions, NSF started funding larger scale things. I'm forgetting the name. What was it before expeditions that allowed you to have multidisciplinary? Irwin, somebody out there doesn't remember the name, doesn't matter.
I don't know.
Driving me crazy. Anyway, that really made a difference. When it came out with funding that said you can bring in your application or your multidisciplinary collaborator into your size funding to go and pursue something. Margaret Martinosi, head of size, was funded under that, I think, for some of her Zebra network. Mm-hmm. And she said this famous quote on a panel, and she laughs at me all the time because I've quoted her many more times than she ever said it, which taught us how to take turns. She said multidisciplinary work is taking turns, right? You don't go out with the brand new algorithmic idea that you're going to publish in NeurIPS. NeurIPS didn't exist at the time. At the same time that you're trying to help that ecologist do their groundbreaking work, you have a willingness to take turns. You go out with your state-of-the-art, but something that will work to let them collect their data. They go collect their data. You get some motivation for the next thing you need to design. So those sorts of programs that are designed to push us to, maybe it's this time not just going to be saying you can include the ecologist, but you can include that community-centered work. And NSF does this, whether it's sustainability or some of the community-centered work you do, but allowing that to come into the more mainstream, particular division focused work. That it's you can get additional money for an REU. You can also get additional money on your grant for bringing your more focused work out into the community and your community into your work. So I think there's just many levers as we start to do this. It's not only about teaching ethics, it's about creating the experiences for the students to have as they're going through, where they're really engaging with the broader community's issues and problems.
So I want to come back to this because I think what I'd love for us to end before we go to the audience for questions is how hard this is. So I think all of, like interdisciplinary collaboration is very difficult. And I think it would be worth like a kind of very kind of frank conversation about that. But over to you, Dean Isbell, for how you would talk back to Krishnan and Janet about their kind of systems approach from the student approach, and what you, as king of the day of Knighterd, what you would wish for this great network of networks to do to make this world possible.
I like that, king of the network. So I think the answer is, we've heard it, but let me emphasize 1.5 things in this. So one is what Knighterd has, what NSF has, what DARPA has. They have the power to convene, which is not a thing that I think that we don't always remember this. They have the power to convene, to bring people together, and to therefore set the agenda, which is the second or half thing that also matters here. And Deborah said this, I think, quite eloquently. They get to set the objective function, right? They say, this is where the money is going to go. And it turns out people follow when you do that. If it's $10 million or $5 million or $100,000, people tend to follow. That is a way of expressing about what the values are, right? And when NSF, for example, many years ago, decided that you needed to explain broader impacts, that changed the way that we did research and the way that we thought. It took a very long time. And for those of you who weren't around at the time, actually I wasn't around at the time, it happened just after. I'm desperately trying to convince myself I'm young here. That, there was a lot of resistance.
Yeah.
But it mattered, right? And NSF is going through something right now about broadening participation. SIZE in particular has been pushing on this for a long time. And it's beginning to change the way people do work. So this is an organization of organizations that have an enormous amount of power to set the agenda. We'll point out, though, you talk about difficult problems, that at the end of the day, even if you take something like NSF, which I think a lot of us like to hold up as a model of merit-based reviewing and those kinds of things, in the end, the community decides whether this gets a 5 or a 4 or a 3 or a 2 or a 1. And it is difficult sometimes to get the community to move. If the community doesn't move, then organizations like this are then put in an awkward position of either forcing it or giving in to that lack of alignment with whatever the community thinks is going on. So I think there's an enormous amount of power. If it were up to me, I would convene, I would change the objective function, I would say these are the things that we care about, this is where the money is going. But in the end, you've got to be able to socialize and bring the community along, or otherwise it doesn't happen. But even in that case, eventually it happens. It just takes a little bit longer. So that's what I would do. I would change the objective function.
So I want to, before we open up for larger discussion, I want to just push on where I was going after Deborah spoke on the hard parts, because I want us to sort of think in that space. So convene, yes. I think the fiscal granting incentives are more compelling to some disciplines than others. So I don't know that a philosopher left to their own devices or an ethicist says, if I work on this philosophical model rather than this one, NSF gives me money. I mean, the humanities and some of the social sciences think in a very different way. The sort of objective function, I think, Dr. Isbell, to use your term, is not the same incentive for all of the disciplines that we've been discussing to sort of bring to the table here. So that feels like a problem. Then there are like very kind of seemingly banal things like lengths of papers, and like I just was talking to a colleague who is historian who's been working with data scientists working with big gene data sets, and they're having a kind of struggle over whether or not they're going to publish and sell, and how to think about the length of the paper. And some in the collaboration feel like they're leaving out everything. Some think the paper's already too long. So there are those kinds of like things. And then there's the kind of industry academia piece that Deborah also laid out. How do we continue to effectively populate the research community when some of our very best students go into industry and never come back? or that there's all of these in the system, in the pipeline, all of these moving pieces that if the extraordinary vision that all the four of you have laid out is going to work, requires new incentive structures, some really hard work. I think the mutuality that Deborah talked about is right, but that is hard to do. So I just wanted to just push us a little bit further on how we get here from this this beautiful dream we have for the future of socially informed, kind of human-centered computing.
So, yeah, I don't know if philosophers are as motivated by money, but I think philosophers and social scientists are very motivated by the idea that people building things in the real world would actually listen to them and want to work.
Fair enough.
Because
yes.
they do want to make the world a better place and to have that kind of collaboration. I think we need to encourage and fund interdisciplinary work and interdisciplinary programs. And for example, the program I'm in is not only interdisciplinary, but it's also kind of intergenerational because it's aimed at mid-career professionals who are getting a PhD part-time. And so my students come in and they are already senior officials doing cybersecurity, or they're doing research, or they're in government doing policy work, and they're coming in to kind of get the theoretical perspective. And so they're bringing something that someone fresh out of college isn't bringing. And so I think also the kind of lifelong learning, multi-generational wisdom is just to think outside the box in all of those ways. But one other thing I wanted to say was just that I was so impressed by the posters of the CI fellows that I looked at, and there are people integrating ethics and social responsibility and user-centered design in these incredibly impressive ways. And so I think keep funding these people is something I can't really stress enough.
Thank you for that.
I think harnessing a lot of what we have and directing it in ways to achieve the kinds of outcomes of interest might be interesting. So let me offer 3 or 4 ideas. We are actually, through the offices of CCC, who is one of the sponsors here, actually bringing together the AI community and the operations research community in a series of workshops with the objective of really getting these two communities who are working on related problems, but don't often go to the same meetings, don't publish in the same kind of journals, though they use the word objective function a lot. They both they do optimization.
We like objective function.
They do optimization, and operations researchers think they came up with that term first, so on and so forth. So, but the point is that kind of. And as an OR person, I like to say that.
That was appropriation.
So this getting these communities to talk to one another and having these conversations that then lead to these cross-fertilization, I think, is one level of engagement. Yes. Another level of engagement is a fellows kind of program. She mentioned the CI Fellows program. We have something called the Data Science for Public Policy Fellows program. This brings in master's, PhD students with social science training, computer science training, brings in an ecosystem of partners who are community, social sector, public sector organizations. Professor Raid Ghani leads it. And it's about 50 students a year. We run it in 5 locations worldwide. Pittsburgh is one of them, but it's one in Africa, one in the UK, and a couple of other locations. But clearly, it's an attempt to try and bring these communities together. And there are other approaches to doing this, but this is a second level at which one could do this. A third is building on the public interest technology idea. This is something that I am the lead person at CMU on public interest tech. Is we've been trying to build something called a scopeathon, much like a hackathon, but different, to teach people how to scope and work on problems, to learn to ask the right questions, learn to determine who the right stakeholders are, which to a large extent is an even more important piece of the puzzle than the toolkit, which you learn in computing, and how to then marry the two together. And the Scopathon, which we had, we have 70 students that took part in it with multiple community organizations. The approach is, can we create a playbook out of that and make that available perhaps for others to consider doing in their communities, in their universities? So these are three ideas. The last one is the NSF AI Institutes, which is something that we've had, 1 round, 2 rounds of, and they've been really very significant investments. It could be interesting to see if one of those institutes at that level could actually drive this idea of pick an area like where an issue like causality and causal inference, which the economists, which the social scientists have thought very deeply about, combining that with the deep capabilities that are coming to the fore with machine learning. This is well understood. Both sides want to do it, but they come at it from different perspectives. I could imagine those kinds of areas really benefiting from a cross-fertilization and investment at the level of an AI institute. So I think those are just four very different ideas.
Thank you for those examples. So before we turn to Deborah and Charles, going to ask folks who have questions to begin to come to the stationary mics in the aisles, and we'll queue up some questions. Deborah, over to you.
Listening to the answers, I of course lost track of the question, but you asked about difficult.
Yes, I mean, you clearly have thought quite a lot about this. I mean, there's lots of, it all sounds really good, and how do we make it really work?
So there are many versions of work. So a lot of folks in the public interest tech context are trying to get people to go into public sector, which I think is a fantastic and wonderful goal. And it's not really how I've designed our programs to date, because when I look at our incoming student population, that's just not going to happen in the near term. And I am pragmatic to a fault. So what I want to do is have students who are coming through the system do what Charles was saying, which is that as they're, I thought of something cute to add to your, before they write a for loop, right? They should be doing a who for and what for loop before they do their for loop. You're welcome to use that. Anyway, that they should be just getting, every startup venture in the master's program that comes through, they do ethical risk assessments. And that's just part of how things get done. And they get to sort of try to then think about negative externalities, right? But I also want to have this notion of the positive externalities, the things that don't get done because they're not hyper-scaling, there isn't a market for them, they're a public good. And so it's our job to bring to them to have that experience. And then they're going to go off and largely, some small number will go into academia and they will have something to base what they're going to put into their broadening participation or their public interest statements as they pursue it. And they're going to have something to give to their students because the students are asking for this.
Yes.
Right?
Yes.
All those posters, they're gone. All those posters that were there, right? The students are asking for it. They're going to do it, and we need to give them enough opportunity to do that. And those who go off to industry, which will be the bulk of them because the industry is growing, which is why our field is growing, they will have had some of these experiences. And they can take that, hopefully, to maybe make a choice to, at some point, go and start a smaller venture that doesn't hyperscale, but addresses some niche or community or subset problem, or they'll do that as a product within the company they join. So it's hard to take this on and have it change people's careers entirely, but I think it can be insidious and start to come in and affect how everybody does their work in smaller ways.
Thank you. Charles?
It's hard, right? So I think the way you deal with hard problems is you get people who like to solve hard problems to decide it's a problem worth solving, and you create a structure that supports it. So, look, I used to do a lot of what I'll call interdisciplinary work with climate scientists, modelers, in an earlier time, 20 years ago. And it was 3 years before I figured out that when they said probability, they meant, actually, I don't know what they meant, but they didn't mean what I meant. And I certainly didn't mean what they meant. And it was difficult. And there was a lot of distrust, a lot of misunderstanding. They would say, well, the computer people can do the computer stuff, and then the scientists will do the science stuff, which irritated me, but then they would get upset. Anyway, it would just kind of go on and on. Oh, by the way, for the record, I have published in the Annals of Operations Research. I am an operations research guy. But I think, and then I would say stuff like that. It was a really bad time. But recently, just to pick on, again, something that happened at Georgia Tech, we created the School of Cybersecurity and Privacy, which is the first inter-college school at Georgia Tech, so reports up to the Dean of the College of Computing. But all of the deans participate, and mostly that's the business school, the liberal arts college, engineering and computing, and every person we hire in that school is jointly appointed with that school and some other schools or department. When we say school at Georgia Tech, we mean department, but everyone else would say we call it schools to, I don't know, confuse the enemy. I don't know why we do it, but we do it. And so we are in multiple schools, and that was really hard. You got public policy people, international affairs people, lawyers, as well as computing people, electrical engineers, mechanical engineers, trying to create a department and just discovering all of these things about the way they view scholarship that feels incompatible. And but they decided it was worth it because we created a structure for them, and it was a chance for them to elevate the problems they care about. And they've worked over 2 years to come up with structures, including things around reappointment, promotion, and tenure, which is the central question in universities, the way classes are taught, the way people are rewarded, in order to try to make something work. You know, ask me in 10 years how it turns out, but right now, the gradient is positive. And I think you just have to do that. You have to put the people together, give them a hard problem, tell them you're going to support it, and if they want to do it, they'll try.
Thank you for all of these really excellent suggestions and really bring to the ground what it is we need to do going forward. So let's take some questions. Please, if you don't mind introducing yourself.
Is this on? Is this on? Okay. Hi, I'm Jean. I'm a CI fellow at the University of Washington. So underlying a lot of these conversations of computing and social impact is the idea of techno-solutionism. But what if after you spend time with the community, after investing a time with them, you realize that tech isn't the best solution? So how do we rethink the narrative of techno-solutionism in this space? And how do we as technologists have the humility to say that maybe we don't have all the answers to all these problems?
Thank you for that. Who wants to take that?
I feel like she was looking at me.
I can give a.
It's because my chair is angled this way, Charles. Tech solutionism, yeah.
Just a quick response. Great question. Just to give you a very concrete example, I think it goes to the question of what the root cause of the problem is. So, for instance, there's a problem we've been working on, which is why do people who are eligible for benefits not actually enroll for those benefits?
Yes.
Okay, this is for SNAP, for food stamps. And you can identify, at least predict who you think these families are that don't enroll. But if you think the problem is they don't enroll because they don't know how to get on the web, and therefore I'm going to schedule a caseworker to go out there, get them on the web, that's an example of the sort of problem that you're talking about. But if we try to understand first what the reason is that they're not actually enrolled, this is something that social scientists adopt as an approach to try and sort of get to the root cause of the problem. And if it turns out that the root cause of the problem is a friction associated with getting signed up or not having a complete understanding of the problem or not wanting to be on government benefits, there could be any number of causes that result in this. Some of those may be amenable to a technological solution, others are not. So if you can't just sort of assume that, oh, this uptake is because of a technical issue, that I'm going to throw a technology at it. So I think the answer is understand the root cause.
Thank you. So let's take a question here, if you don't mind introducing yourself.
Absolutely, thank you. Good afternoon, everyone. I am Jasmine Berry from the University of Michigan. And alongside the title of the panel, How Technology Can Be Useful for Society, it got me to thinking about maybe in the past few years, some of my colleagues and I, we have been very adamant about talking with members within our society about the products that we've been building. And what we realized is that we grossly underestimated how much interest the public has in the
the AI solutions that we're constructing, to the point where they're very interested in the ethics that we're building, the principles, and it got me to thinking. They want a higher stake in the direction that science goes in the very near future. So much so that decentralized science is now becoming more of a thing, especially with the use of blockchain and digital ledgers. So I wanted to know, I guess, from your opinion, does either Knighterd or your institution or organization, are you planning to somehow either work with decentralized science organizations to maybe give people more of a voice in how science is built and ensure that their ideas and their thoughts about how AI is being built is actually incorporated? And what do you see for that in the near future? Thank you.
Thank you. Who wants to take that?
I was going to consider, then you mentioned blockchain, and I decided I wasn't going to. Joking. Where are you? Okay, thank you. I'm not going to fully answer it. It's all of it together. What is AI as a thing, right? So I was reminded from the previous panel of my incredible colleague Helen Nissenbaum and her work in contextual integrity. And in so many things, the context is what matters. And who, is it about, something about policing, or is it about, treatment of arthritis? Another colleague of mine, Emma Pearson, who did some incredible work about undertreated arthritis pain in different contexts because of the nature of the training of those ML algorithms. So I think it's important to separate out those problems, and then it's a particular subset of people working on things. Think about what's going on with long COVID. There is some good progress happening in bringing to bear researchers and technologists to try to bring tools to patients who are advocating for themselves to try to understand these range of symptoms. And I think there can well be spillover to other chronic conditions that have been poorly understood and not taken as seriously as they need to be. So I think it's hard to come up with a general answer, but that we certainly have researchers who are looking to engage more with the communities that that are impacted. It's a difficult thing. I don't think there is a thing that is AI, and I don't think that there is. I don't think that a blockchain or anything else is a solution to democratizing anything, right? If we're going to bring more democratic pursuits to things, we have to work up and down the socio-technical system, from the incentives to everything else. So we shouldn't be overly excited by an underlying technology somehow being able to make that happen.
Thank you. Over to you.
Can I give it to him? He hasn't asked a question yet. I've already asked a question before, so maybe
Sure.
Yeah.
Oh, sure.
Just in case we're running out of time.
Hello, everyone. My name is Emmanuel Johnson. I am a CI fellow at the University of Southern California. And listen to the panel. One of the things that keeps coming up is this notion of interdisciplinary collaboration between the social sciences and computing. And one question I had, do you all feel that we are preparing students to be collaborators and to collaborate outside of discipline? One, and if we are, can you share some models that have worked? And if we aren't, what do you think we need to do to better prepare students to be able to interact with people outside of computing discipline?
Thank you.
So I think the answer is both yes and no. I think a lot of the incentives, particularly at the graduate level around research, are not set up that way very well because it's hard. It's a hard thing to do. On the other hand, I think increasingly we're seeing a lot of programs at both undergraduate and graduate level that colloquially have been called computing plus X or X plus computing, where we try to bring people together to do this. The cybersecurity thing that I mentioned before is an example of that in my own university, but a lot of universities have something like this. The problem with a lot of those is that, well, there's a couple of problems, but one of the big problems with a lot of those is that it becomes either computing dominates or X dominates, and the people involved have a hard time creating something new. Where I've seen it sort of succeed, either at the programmatic level or at the sort of individual research projects, is when people sort of believe that they were creating a new thing. that was neither the computing nor the X or the math of the X or whatever the two things are, but they were trying to invent something new. But all the incentives for inventing something new, I mean, there are disincentives for inventing something new, a new discipline, particularly in academia, right? People always want you to find the conference or the paper, have the community that cares about you. And if you can't do that, then it's sort of, it feels difficult. Actually, I think in practice it's not, but it feels very difficult to kind of go through that. So I think the answer is both yes and no. There's a lot of effort to do this. People have to be, to use a term someone said earlier, appropriately humble about their own participation in that. And if it can be expressed positively, that there's a thing that we're getting to together that will be new and different, then you sometimes get quite a bit of success.
Thank you. Last question, please. Thank you.
Patricia Ordonez from the University of Puerto Rico, Rio Piedras. I wanted to ask you, well, first of all, thank you for the work that you do. And Deborah, particularly your work in broadening participation is part of what inspired me to do the work in Puerto Rico. But this is one of the things. I didn't know about her work until I got to Puerto Rico and I was trying to do computer science. Like, what can we do to get that work? It seems like if you do science, you can't broadcast what you're doing for the community. And how can you change that? Like, can there be a term that NITRD can use to do like equity enabling research, where you put into your research you put equity?
Take that as a suggestion.
Yeah.
I don't know if others as a quite
like-
good suggestion. But did folks want to weigh in?
Okay.
Yes, I think that's a tremendous idea. I was very inspired when I visited the university in Puerto Rico. I don't remember, maybe 2004 or something, and saw the number of women engineers there. And I immediately wanted to recruit them all to my center and just blow my site visitors out of the water at how many women, but their families didn't want to send them that far away. I was in California at the time. But seriously, I think that's a really interesting idea, how broadening participation has, for good reasons, become a little bit more formulaic so that effort is successful and not just people riffing on how to do it. But now bringing some of that back into the motivation for the proposal that broadening participation is connected to, that it's woven in more, it would be great to figure out how to really elevate that.
Thank you. So let me just say, you all have each in your own fields been extraordinary scholars and researchers, and you now are really just extraordinary leaders and moving us to a different place in how we think about technology and society. So it has been a true honor for me to be in conversation with you, and we are also grateful for your presence. So thank you, Dr. Abate, Dr. Krishnan, Dr. Estra, and Dr. Isbell. Thank you very much.
Thank you.
Okay, so we're now going to I invited my NSF colleague, Irwin, to send us off.
All right, good evening, everyone. Oh, come on. Good evening, everyone. There we go. So my name is Irwin Yanchanani, and I have the honor of serving as the Assistant Director for Technology, Innovation, and Partnerships, leading the newly established directorate at the National Science Foundation. And it's a pleasure to be with you today, and it's a pleasure to be able to draw this symposium to a close. Some of you may know I was previously in SISE for 8.5 years, so very intimately connected with the Knighterd program. So I know it's been a pretty stimulating day, a lot of great discussion. This panel was fabulous here at the end, and I stand between you and the reception. So I'm going to try to be brief, but I think we have to take just a moment to acknowledge what an extraordinary set of conversations we've had today, and really what an extraordinary day this has been, and especially the fact that we've been able to do it in person here today after a couple of years. So I have had the fortune of being connected to the Knighterd program one way or the other for almost 13 years now. And as, in fact, some of you may know, helped organize the 20th anniversary symposium a decade ago. And I have to say that I couldn't have imagined when we were standing there 10 years ago that we would be back here in this fashion. Couldn't have imagined certainly all the things that have happened, all the progress and all the challenges that have emerged as a result as well. But one thing that I want to emphasize as we wrap up here today, when we closed off that symposium 10 years ago, I think many of you who were there would share these feelings with me. We thought we had done a pretty good job. We thought it was a pretty good symposium overall. A really nice tribute to what had happened in the first 20 years and a look ahead to the future. And I think that this symposium has managed to top that. Don't tell anybody who was there 10 years ago, though. So we have heard from a fabulous set of panelists and speakers about 3 decades of investment in networking and information technology, how that investment has been convened, coordinated, enabled by the Knighterd program. And it has not only advanced science and technology, but it has also allowed for those scientific and technological advances to touch all of us in terms of our daily lives, right? Change the way in which we work, we play, we consume information, and so forth. We've also heard about how those advances have served to impact, at the end of the day, our economy and our global standing. They've created new jobs, they've created new businesses, and they have created regional and national scale economic growth as well. If you think about just data, for example, the pace of discovery in nearly every field of science and engineering, nearly every sector of our society has accelerated dramatically as a result of low cost, low power sensors, which collect data, allow us to harness data, the access to unprecedented amounts of data, and then AI and machine learning that's allowed us to be able to extract meaningful insights and real-time decision-making, facilitate real-time decision-making. That's just in the last 5 or 10 years. We've also heard how the Knighterd program has really evolved itself too over the course of the last 10, 20, 30 years as well. So I've lived that in some sense on the front lines, but I think today has even deepened my own appreciation for how the Knighterd program and the agencies that are a part of the Knighterd program, not just NSF, but all of the agencies that are a part of the Knighterd program, really play a role in convening and coordinating and in engaging, leading to the contributions that we see. And especially so the leadership and the team at the National Coordination Office and all across the federal government, for that matter, who really work tirelessly day in and day out to move this program forward. At the same time, we have also, I think, recognized just how much more there is to do. Our scientific breakthroughs and our technological innovations have demonstrated the power of disruptive change in the world. But they have also demonstrated the challenges that lie before us. So the barriers of entry in being able to be at the table to design and shape new systems are still too high. The biases that these systems can perpetuate are profound. And the adverse implications that these systems can have are consequential, particularly on those who are most vulnerable. And so, something that Charles said earlier this afternoon really, I think, resonates and I think will stick with many of us. If you're not in front of me, I don't even know that you exist. And I think that's really telling, and that's something that we should carry forward as we think about what we do. So going back to that example of data, I talked about the unprecedented impact of access to data over just the last decade. Well, there's the flip side to that. It can drive progress in every field and sector, but for all the good that data provide, we also have to be conscious of just how comprehensive a data set actually is as we try to draw conclusions from that data set. We also have to be mindful of all of the security and privacy considerations, the civil rights and civil liberties considerations that need to be factored in when we try to utilize those data for a variety of different applications and contexts. And so there is clearly much work before us and much more evolving that we need to do as a community and as a Knighterd program. It's not just that transistors are getting smaller. It's that the intellectual effort that people put into making that a reality is what shines through. We've heard, for example, today about the increasingly interdisciplinary connections that are required. Computer science benefits, but computer science benefits, and it also benefits from so many scientific fields. We also have to pull together multifaceted teams, not just from government, not just from academia, not just from industry, but also civil society, communities of practice. We have to think about the heterogeneity in terms of the different types of institutions that are at the table or that should be at the table. You know, my director at the National Science Foundation, some of you know, likes to talk about partnerships that expand the geography of innovation. We have to harness that geography to an extent in order to be able to inspire the technical innovation that we want to see, and in order to ensure that it positively touches and lifts up all of our society, regardless of background, regardless of socioeconomic status. We've also heard about the need for continued investment in high risk, high reward work. Part of the value of Knighterd, I heard someone say earlier today, is seeing the unseeable. And so we have to foster that creativity and that ingenuity along the way. That same creativity and ingenuity that we saw at the poster session featuring our CI fellows, by the way, many of you who are still in the room today. And I think perhaps most importantly was what we heard on this panel at the very end. Our field has changed over the last 30, 20, 10, even 5 years. We are no longer strictly a technical field. We have to think of ourselves, we must increasingly be a socio-technical field that draws in those different disciplinary perspectives that serves to shape and inform the research that we're trying to pursue. So I'm going to end where we started this morning, actually. Ayanna Howard, in that first video that we played as folks were walking into the room, said, I do feel that my own research has benefited from the collaboration of the agencies. I would not be able to do what I was able to do across the lifeline of my research unless the federal agencies had been able to coordinate, end quote. And then we heard Dario Gil on that video a few minutes ago talk about how it's high time for us to shift our emphasis on not just digital for digital, but digital for physical. And we really need to reorient the effort toward creating a better physical world for our planet and for us as humans as well. So as we draw this symposium to a close, we know that the achievements of our field are incredibly enormous. And we have a tremendous evidence base over the past 30 years to be able to build upon. But we also know that the challenges, and I'm going to call them opportunities, are huge that lie before us as well. And so it's incumbent upon us to pursue that broad agenda that will allow us to look back 5, 10, 20, 30 years from now and recognize that the world is a better place for the continued investments that we've made through the Knighterd program. If we just think about what we've been through as a society over the last 2 years, if we just think about what we've been through as a society over the last 2 weeks, the world needs that from a socio-technical perspective as we go forward. And so with that, before I close, I want to take just a moment to acknowledge all those who have made today possible. If we can bring up the slides, thank you. So we wouldn't be here today without the leadership of these sterling folks on this slide. The leaders of the Knighterd program. Leadership always starts at the top. Now, of course, I can't see the slide, but that's okay. This is the first time, I think, all day we're really using slides, which is, I think, innovative in and of itself. So if you look at this group of Knighterd directors and deputy directors, they are the ones who have helped to champion and steward and lead this program day in and day out, going back over the course of many, many years. And several of them were in attendance today. So if you're a Knighterd director or deputy director, past or present, could you please stand and can we give you a round of applause? We've also learned, I think, not just about our discipline, achievements, and opportunities ahead, the exciting future, but we've also learned about the enormous talent that we have in our field in terms of spectacular speakers who were on this stage today, even if they want to argue about CS versus operations research. It's okay. So let's give our speakers, our panelists, our moderators a round of applause one more time. And by the way, those of you who checked out the poster session during lunchtime, I'd like to give a special shout out to the CI Fellows. In fact, if the CI Fellows are still in the room, if you could please stand. Come on, don't be shy. You can stand. This is the next generation. When we look back 30 years from now, you all will be on this stage, on this podium. You all will be the ones speaking. And so I hope you walk away as inspired by these conversations as I was today. And then lastly, sorry, I have a couple more thank yous. Bear with me here. I just want to take a moment to acknowledge all of the work that went on behind the scenes to make today possible. So there's a Symposium organizing committee. You saw many of them on the stage as moderators, but not all of them. So if you all could please stand, and I think that they're on the next slide here. I just want to read out the names. Bob Bonneau, Liz Bradley, Richard Conroy, Cami Roberts, Chuck Romine, Ann Schwartz, Jim St. Pierre, Kathy Yellick, and Ben Zorn. Hopefully I didn't miss anybody. If you all could please stand. So I watched, for the most part, as they worked incredibly hard to figure out how to capture the tremendous diversity of our field in one day. So kudos to them. And then if they're still around, the CCC CRA staff, I know Liz acknowledged them this morning, but if you all could stand, starting with Ann and Peter and everyone else, if you all could stand too. And similarly, the NCO staff, the National Coordination Office staff. I know we have a number of technical coordinators here, but I want to call out those who were particularly instrumental in this event. So Virginia Moore, who's not here, couldn't be here today, but Nakia, Diane, Diana, and Adrian, if you all are in the room, let's give them a round of applause as well. It has been a pleasure to work with them to, pull this off so seamlessly over the last day or so, and particularly to have to do it on sort of a schedule where we didn't quite know exactly when we would be able to do this. We had started planning for December, and then we had to shift a couple of times in light of the events that we've seen. Finally, thank you all. And thank you to those who are watching on the webcast, the live stream today. You're being here and you're engaging in the Knighterd program, past, present, and future, is what is key to its success. We wouldn't have all the accomplishments were it not for all of the research community that really helps to foster those. So thank you to all of you as well. So with that, I invite all of you to move upstairs to the reception. It's a great outdoor venue. I think many of you saw it at lunchtime, but I'll just invite you to go up there one more time. And in an hour, I guess 51 minutes, the Spy Museum will be open to this group to be able to tour the exhibits. Just one request, please don't take any photographs in the exhibit spaces. The Spy Museum has been gracious enough to host us, so we'd like to honor their request and not take any photographs. Thank you again. We'll see you down the road, and we really appreciate everything.